So, hi everyone. Today we will be talking about a new mechanism which can be taken as an alternate for attention that is used in transformers and eventually in LLMs, that is Mamba. So, you might be hearing this in some of the pages that now some LLMs are now getting built over the mechanism of Mamba and they are now ignoring attention. They don't use attention anymore. So, what is Mamba and how it is a better alternate for attention and in transformers? So, let's check it out. So basically, as I already mentioned, Mamba doesn't use attention. Rather, they use a new mechanism called as selective state space model. So we will be talking a little about this particular thing, that is triple SM, in detail and try to understand how it is different from attention. So first of all, let's try to understand what are SSMs. State selective models are used in economics or statistics. You might be hearing of models like Markov chains. That is a type of SSM model where the model behavior or prediction depends on the current state of the system. The term state here refers to a set of variables that defines the current configuration of the system. So don't worry, we will be taking an example. There you would be able to understand better what do we mean by a state, how do we are saying that the behavior depends upon the state of the system, all these things. So in a SSM, these are the major three components, that is a state, different conditions, state transition, a system that evolves, transition between one state to another state upon time, and state dependent behavior. So obviously once the state changes for a system, if it was in state 1 and some transition happened, it went to state 2. In that case, how the system behaves, that is called as state dependent behavior. So one of the most known example is Markov chains that you might have heard. So now let's take an example of a simple Markov chain in a weather model. So let us say you're modeling a weather system which has two possible states. One is either it can be sunny or it can be rainy, right? Sun is represented by S, rainy by R. Transition probability. So basically, if today is sunny, what is the probability that tomorrow would also be sunny or tomorrow would be rainy? So here you can see that this is the condition that we are giving. 0.8 probability that tomorrow would also be sunny and zero point 0.2 that tomorrow would be rainy. Similarly, if we talk about if today is rainy, it's then what is the probability of tomorrow be it raining and tomorrow it be sunny. So now we have a set of probabilities that we have. So depending upon today's state, so today if it is sunny, we will be trying to calculate the tomorrow state, and if today it's rainy, we will be trying to calculate what can be the possible state tomorrow. So this is the transition matrix that we have got. So if you, I try to explain this to you, 0.8 basically, the first column represents sunny, the second column represents rainy. So for the first current state, if today is sunny, 0.8 is the probability that tomorrow would also be sunny, and 0.2 is the probability that tomorrow would be rainy. If today is rainy, 0.4 is the probability of having sunny tomorrow, and zero point 0.6 it to be rainy. Now here you can see the first row represent transition probabilities from sunny to sunny, sunny to rainy. Second, rainy to sunny and rainy to rainy. Initial state distribution, assume that it to be 50-50. That means 0.5. So today the chances of sunny is 50% and same for rainy. Now after one day, how does that state transition may happen? So here you can see that today's probability is 0.5, 0.5 into, we would be multiplying the transition matrix that we have got, and hence tomorrow's probability are 0.6, 0.4 after 2 days. Now this is very interesting. So tomorrow's probabilities would be now current's probability, right? Because now it is asking for tomorrow, day after tomorrow. So if today is Thursday, we calculated the above probability 0.6, 0.4 for Friday. Now it is asking what would be the weather on Saturday. So we would be using Friday's probabilities and again multiplying the transition matrix to get to the final probabilities. That on Saturday, this is the probability of having sunny or rainy system. So this is how a state selective model works. You have transitions, you have states, you have a next state coming in. So this is how a state selective system works out. Now there are a few major matrices that are getting used in a state selective model, that is ABCD. So if you have read about attention, there we have got KQV matrices, right? Here we have got ABCD matrices. So let's try to understand and very quickly what does ABCD stands. So as you can see, x plus xt plus 1 equals to a into xt plus b into ut. Xt represents the state vector at time t. So t plus 1 is what would be the state vector tomorrow if we consider the weather model again. and y is the what would be the output tomorrow. So these are two different things again. X t plus 1 is the state vector that would be tomorrow, and yt is the actual output. If we see here, the state vector xt at time t will represent the probability of being in each state, that is sunny or rainy. So xt is basically the probability of sunny or rainy on that particular day. Transition matrix P defines how the states evolve. Hence, P is equals to a combination of A and B. Right. So A and B represents the transition matrix, how it works. So A, the state transition matrix that defines how the system states evolve from one time step to another. So A equals to 0.8, 0.2, the matrix that we were talking about initially, that is actually A in system of state selective models. B, the input matrix that describe how external inputs affect the state. Now, in case of whether there are no external inputs coming in, right? So, for example, an external input could have been a storm coming from West Bengal. Say that is not happening. Hence, the value for B would be 0. C is the actual output matrix that maps the system state to the observed output. So it is helping you to convert xt plus 1 to yt. Just try to understand this. We are getting the state probabilities for tomorrow are different from the actual output, right? That is why they are getting represented by x and t. So how to map the tomorrow's probabilities to y? We would be using C. So in this case, the states matrix is similar to output matrix. C equals to an identity matrix 1001. D, the direct transmission matrix that defines how external inputs directly affect the output. So again, if you understand, A and B relates to the state probabilities, while C and D relates to the output, actual output. These two are not the same thing, the state variables and the actual output, right? So this is how a state selective model works. This might be a little complicated. Just pause a bit, read what we have written. I think you would be able to get it. Now, coming back to Mamba, we will try to understand why Mamba is considered a better alternate for attention. Sequence modeling, talking about transformers struggles with a very long text due to complex attention calculations. So, if you know, if you're 1,000 words, we would be forming a attention matrix of 1,000 cross 1,000. This is very, very complex, right? Because once you're going for computation or even for latency, this would be very, very high. But and that is why going with a long context is a little difficult. Very long context, a very, very long text, transformer may struggle. Talking about selective focus, Mamba uses SSMs for selective focusing. It means it can dynamically adjust its focus based on the input it receives. So in case of attention, if you already know how attention works, every word uh, is able to see all the other words. So, for example, if we take a sentence, the fox sat on the mat. Now, here the probability of all the words is visible to fox. Now, this is computationally very heavy. You won't require it. Now, if the context is very large, this becomes even more unbearable. But in case of selective focus in Mamba, you are not focusing on all the words. The next move from focus won't be dependent upon all the words in the sentence, right? So if you read this particular example, if Mamba is reading a story about rainbows, it can focus on different aspects depending on whether the context is scientific or mythological. So if it is able to make out in what context rainbow is used, eventually it can eliminate all the other contexts on its own. It doesn't consider also whether mythology might come in, and hence it is called as states selective focus. It is more efficient in terms of computation memory usage. Hardware optimization is also there. And one more very important feature that is present is parallel computation, what I was reading about. Hence, Mamba leads the chart for me because right now a major issue with LLMs is the training part because the attention metrics are huge and inferencing is also taking a lot of time. Now we would be jumping a little more into how SSMs help Mamba in selective focus because this is the entire distinction between attention and Mamba. So, for example, Mamba receives a story, an input such as a story about rainbows. It first converts the text into vectorized representation. Then it extracts the context from it. For example, if the story mentions light refraction, Mamba infers a scientific context. It understands that rainbows are used in a scientific context. They are not used in stories, and hence all the context around stories, all the knowledge around stories would be kept aside. It won't be using it. Hence, it has reduced its scope, getting the context. If it mentions pot of gold, the context becomes mythological. This happens through a contextual attention mechanism where weights are assigned to the parts of index to determine relevance. I think we won't be jumping into a lot of mathematics, but just try to understand what does selective focus mean. Dynamic focus adjustment. Using SSM, Mamba adjusted its model's internal state to prioritize specific areas of focus. In scientific context, the model activates path or parameters related to physics. In mythological, the parameters that relates to mythology or history might get activated, right? And hence, it is not wasting out its energy on all the different contexts that doesn't relate also. Hence, the identification of the context story that is coming into this case of SSM is making the entire difference between attention and Mamba. Sparse computation, only relevant parts of the model are activated, hence, the entire model is never activated, and hence, it is faster. Output generation, once the selective focus is applied, Mamba generates responses. Feedback loop, if new input shift the context, Mamba readjusts its focus dynamically. So eventually it might be the case that initially the text talks about scientific rainbows, like in terms of science, and eventually by then it turns into mythology. So hence it has got that particular adjustments that it can dynamically shift its focus also. So when to use attention in transformer? General purpose application, tasks like language translation, rich context handling. When the input requires capturing long range dependency effectively, unstructured data. High computational resources are available with you and customization is required. Easy fine tuning is there because right now attention has been explored to a lot of depth. You can see different types of models are coming in, hence it has been explored a lot. So people are more used to attention and it is able to capture context handling pretty good. So I won't. So this is the case where attention should be used. When to use Mamba? I think this is very important. Domain specific tasks, constraints are resources are constant because you don't have that much of GPU CPU to run things. Real time processing is required. Sparse data relevancy, only when only parts of the input are important, and dynamic contexts are required. Hence, right now Mamba hasn't been explored a lot, but I think when I was reading the paper, it did make a lot of sense to me because one limitation that I always thought attention had was this huge attention matrix. And every time every word doesn't require to have context from all the other words, right? You need to be have a mechanism which can get context, and then depending upon the context, can focus on the words. So this is how Mamba works. If you wish to test out some Mamba models, you just rush to Hugging Face, search for Mamba, and there are a few popular models like Codistral is there, Falcon, Mamba Vision, Mamba 2.2, which is available, which you can try out. Nvidia has outputted Mamba Vision. Recently, Nvidia has released Himba also, which is a hybrid Mamba architecture. So all these models are available as open source. Just go try it out and let us know how you feel about Mamba. I think Mamba would soon be an good alternate for attention because attention is leading to a lot of restrictions in terms of memory usage and latency, which I think Mamba can solve out. Thank you so much.